All right, Math 2, here we go. We are now in Unit 5. So here's Lesson 5-1, the Polygon Angle Sum Theorem. So this unit is mostly going to cover quadrilaterals. So those are polygons with 4 sides. Our question today is, why is it helpful to use the exterior angles of regular polygons when looking for the interior angles? So I'm looking for interior angles. Why do I want to use the exterior angles to do that? So hopefully by the end of this lesson, you'll know that answer, and you will put that as your summary. Don't forget to write your summary. Answer this question. All right, so the word polygon. Basically, a polygon is a shape whose sides are line segments. So we can't have curves. So like a rectangle, that is a polygon because its sides are, lines, segments. And a triangle and an octagon and all that other stuff. Now, there are 2 types of polygons. There is convex polygons. In a convex polygon, the angles are pointing out. So none of the angles go inside. So you can see here I drew arrows. The angles are all pointing out. So the corners point out. And this is what we're basically going to be doing in this unit. So if the word convex comes up, that's just kind of all the stuff we're already doing. Now, there is something called a concave polygon, and both of these have 4 sides. 1, 2, 3, 4. 1, 2, 3, 4. So they both have 4 sides. The difference is this one is convex, where all the angles are pointing out. This one has one angle or one corner that points in instead. And so that's why it's concave, because it caved in on that side right there. So that would be a concave polygon. Most of the polygons that we do are going to be like this. Like, there are concave shapes out there, like a star. It has sections of the star that point in. But we're going to be focusing mostly on convex polygons. So just in case that terminology comes up in homework or something like that, that's what it's talking about. All right, so the first thing that we have here is called the Polygon Angle Sum Theorem. Now, the Polygon Angle Sum Theorem says the sum of the interior angles of a polygon, so if you add up all the interior angles, it's always going to be equal to 180 degrees times n minus 2. What's n? N is the number of sides. This makes sense because we already know that we have a triangle. A triangle has 3 sides, right? So that's what n would be equal to. So I would do 180 times 3 minus 2. What's 3 minus 2? It's 1. So 180 times 1. And we already know by the triangle sum theorem that a triangle has 180 degrees for the sum of the interior angles. All right, and it works for like a quadrilateral. So let's take a rectangle or a square or something like that. That has 4 sides. So the n is 4 on this one. Now let's think about this. If this were a square, all 4 of these angles would be 90. 90 plus 90 plus 90 plus 90, that's 360. So a 4-sided object, a quadrilateral, should have 360 degrees in it. If we use our formula here, we would do 180 times 4 minus 2, because n is 4, and we get 180 times 2. And that's 360 degrees, which is how many degrees are inside of a square or rectangle or parallelogram or whatever. So we can keep on doing this for any number sided. So if we had an octagon, n would be 8. Moving on, the exterior angles of a polygon. So we know that our interior angles are in here. So these are interior angles. Our exterior angles are going to be these ones. Okay, so if this is an interior angle, this one right here would be an exterior angle. And what we notice here is the interior angles and the exterior angles will make a straight line. So they're supplementary. So the interior angle plus an exterior angle is always going to be supplementary. They're always going to add up to 180 degrees. Okay, and we have several interior angles since this is a quadrilateral, 4 sides. This would be another interior angle. This would be interior angle. And this would be interior angle. So the polygon angle sum theorem says that all of these interior angles should add up to 180 times n minus 2. The exterior angles of a polygon are different though. The exterior angles, remember the exterior angles are always linear pairs with the interior angles. The exterior angles, no matter what, no matter how many sides we have, if you've got a triangle, if you've got a quadrilateral, if you've got a 20-sided object, the sum of the exterior angles is always 360. Every single time. It's always going to be 360. Now, this is part of the reason why we have an answer up here. Why do we use the exterior angles? Well, we always know the exterior angles add up to 360. Whereas on the interior angles, their sum changes based on how many sides they have. So it's more predictable to use the exterior angles because we always know what they're going to add up to. Whereas we don't always know what the angles are going to add up to when it's a many-sided object because it's going to change every single time. But no matter how many of the sides, the exterior angles out here are going to add up to 180 degrees or 360 degrees. The interior and the exterior angles together are linear pairs, so they add up to 180. All right, you need to know some terminology for naming sides. So let's fill in this chart here. The polygon with the least amount of sides would be 3, because 2 sides wouldn't make a shape. It'd just be 2 lines. So we know that one is, of course, a triangle. Okay, what's the sum of the interior angles? We know by the polygon angle sum theorem that this is going to be, or the triangle sum theorem, this is going to be 180 degrees. What's the sum of its exterior angles? Well, we said earlier, the sum of the exterior angles was always 360. If it has 4 shapes, what's the name? The name's not square, it's quadrilateral. A square is a type of quadrilateral. I always spell this wrong. There's only one L right here. So, all right, so it's a quadrilateral. So what's the sum of the interior angles of a quadrilateral? Well, I do 180 times 4 minus 2. We did that earlier. We got 360. What about the sum of the exterior angles? The sum is always 360. All right, next one. If we've got a polygon that has 5 sides, what would we call it? We would call that a pentagon. Okay, how many degrees would that have? Well, we would do 5 minus 2, which is 3, and then we do 3 times 180, and we get 540. What are the sum of its exterior angles? Still 360. No matter how many sides, the exterior angles are going to add up to 360. All right, what do we call a 6-sided object? 6-sided polygon. It is a hexagon. Okay, what's the sum of the interior angles? Well, I would do 6 minus 2, which would be 4. 4 times 180 is 720. I don't know if you've seen the pattern yet, but basically we're adding 180 each time. And then the exterior angles are 360 degrees. 7-sided object, usually called a heptagon. I've also seen it called a septagon before, Kind of sounds like a transformer, but whatever. I think our books will call it heptagon, though. So how many degrees? So I do 7 minus 2, which is 5, and then 5 times 180 would be 900. And then the exterior angles, still 360. 8-sided object would be an octagon. Okay, so I would do 8 minus 2, which is 6, and 6 times 180 is 1080. And the exterior angles are still 360. 9-sided object. Probably haven't heard of this one before. It's a nonagon. So I would do 9 minus 2, that's 7, times 180, I get 1260. Again, I'm just adding 180 each time. And that'd be 360 degrees for the exterior angles, because it's always 360 degrees. Okay, last one that you really have to know is a 10-sided object, and that would be a decagon. And then we would do 10 minus 2, which is 8, and 8 times 180 is 1440. And we get 360. Now, if we keep on going, there are names for all the other ones. Like an 11-sided object is called a Hendecagon. A 12-sided object is called a dodecagon. But we're not going to worry about that. I just want you to know from 3 to 10. After that, it's okay to, like if you had a 32-sided object, there's an actual name for a 32-sided object. But what we're going to do from here on, after we get to 10, is we're just going to write the number and then gon. So we would just call this a 32gon. Because remembering all those other words, all the other, I think they're Greek words, that's just too much. So we're just going to say anything after 10. So an 11, instead of a hendecagon, we'd say it's an 11gon, 12gon, 13gon, 14gon. So 32 sides would be a 32gon. All right, so how would I know the sum of the interior angles if we have 32 sides? We plug it in up here. So we do 180 times 32 minus 2. So this would be 180 times 30. And if you break out your calculator, it ends up being 5,400. And then still, we get 360 degrees. Now remember, this is the sum of the interior angles. This isn't each interior angle. That would be ridiculous. So this would just be what all the interior angles add up to. All right, sometimes we're going to see polygons that we call regular. So a regular polygon would just be one of these polygons where all the sides are the same measurement, so they're congruent, and all the angles are the same measurement, so they're congruent. So if I had a regular pentagon, so if I had a regular pentagon, and I wanted to find out one interior angle, if it's regular, all the angles are the same. So I would just go, okay, a pentagon has 540 degrees. And then I just divide by the number of sides, 5. So here, 5 goes into 5 once, 5 goes into 40 8 times. So we get 108 degrees. So inside of a regular pentagon, each interior angle is 108. So I just took the total number of degrees inside of a pentagon divided by the number of sides. For the exterior angles, if I only wanted one exterior angle, I'd take 360, because that's the sum of the exterior angles, and then I'd divide by 5. So the exterior angle, 5 goes into 36 7 times with 1 left over. And then we get 5 goes into 10 2 times. Now look at this. What do these two add up to? These two add up to 180 degrees. Because we said up here that the interior angles and the exterior angles always add up to 180 degrees. And so here's our interior, here's our exterior, and it's adding up to 180. So that will happen every single time. All right, let's do some practice problems, and then you're done. First practice problem. We're going to find the measure of each interior and exterior angle of a 20gon. Okay, so I said earlier on the notes, the question was, why is it helpful to use the exterior angles of a polygon when looking for the interior angles? All right, so we've got a 20gon. To find each interior angle, remember it's regular, and my lights just went off because I haven't been moving enough. So let's go to this. There we go. All right, so here's what I could do. I could find out how many degrees are in a 20gon on the interior angles. Remember, that's 180 times 20 minus 2. And then divide by the number of sides, which is 20. So I could do all that work if I wanted to, but I'm not gonna. The reason why I'm not going to is because it's easier to work from the exterior angles. I don't have to do any calculations for the exterior angles. I know that the exterior angles, they always equal 100 or 360. So if I wanted to find out how much each exterior angles were, I would just go, okay, since it's regular, all the exterior angles are the same and all the interior angles are the same. I just divide by the number of sides, which is 20. Let's see, the zeros would reduce. I'd divide by 2. 36 divided by 2 ends up being what, 18? Okay, now I know that my exterior angles are 18. Okay, I still don't need to use the 180 times n minus 2. Because now that I know this is 18, I know that the interior plus the exterior is always going to be 180 degrees. So if I want to find my interior angle, I would just add 18, because that's what my exterior angles are. And now I have this equation. Interior plus 18 is 180. So all I have to do is subtract 18 from both sides. And now I have that the interior angle, each of the interior angles, because they're all the same, would end up being 162. And that's why we work from the exterior angles. The exterior angles, we always know are 360. We don't have to do this calculation of 180 times n minus 2. So find our exterior angle, and then subtract that exterior angle from 180, and that gives you your interior angle, because these two are linear pairs, and they have to add up to 180. All right, next problem. I've got a pentagon. There are 1, 2, 3, 4, 5 sides. I want to find this exterior angle. I'm missing this interior angle. You have a couple ways you can approach this problem. You can say, okay, I know that all of these angles here should be 180. So the interior angle sum should be 180 times n minus 2. And n is 5 in this case. So we could say, okay, 180 times 3, was that 540? So one thing I could do is I could go, okay, I know that all 5 of these, because I don't know what this one is, I could go, okay, 540, and let's subtract all 4 of these angles, and whatever is left would be here. And then these two should add up to 180 degrees, because these are linear pairs right there. So that's one way to solve the problem. The other way to solve the problem is we could say, okay, well, I know that 105 and this angle right here should be equal to 180 because those are linear pairs, so that's 75. 94 in this angle here, that'd be 86 because that equals 180. 123 in this angle here should be 57. 180, yeah, 57 degrees. And then this one here and this one, it should be like 63. Yeah. So what I could do is I could do this right here and work from the interior angles and then solve, or I could find all my exterior angles and subtract from 360. So I'll do it both ways. So one way is I can say, okay, x plus 75 plus 86 plus 57 plus 63 equals 360 degrees, because the exterior angles always add up to 360 degrees. So I would add all those numbers together. So I haven't done that yet. I probably should have done that ahead of time. So 75 plus 86 plus 57 plus 63 equals 281. So this would be x plus 281 equals 360. Then I can subtract 281 from both sides. And I get 360 minus 281, I get 79. So there's one way to solve for x. Find all these exterior angles and then subtract them from 360. And what you're left with is our last remaining angle. If I did it this other way, I would say, okay, I'll call this one like y or something like that. So I could say that y plus 105 plus 94 plus 123 plus 117 equals 540 degrees. Because I found out that using the polygon angle sum theorem that a pentagon has 540 degrees. I'd add all these together and get, was it 439? I think it's 439. Okay, then I could subtract 439 from both sides. If I subtract 439, I'd end up with 101 degrees. So now I would know that this angle is 101 degrees. And then I know that x plus 101 should equal 180 because these two are linear pairs right there. So I'd say x plus 101 equals 180, subtract it, and we still get 79 degrees. Same answer. One works from the exterior angles, the other one works from the interior angles. Two different ways to approach it. You can kind of see that there's less math over here. You choose. All right, the sum of the interior angles of a polygon is 5940. Okay, some of you are going to struggle on this one because you don't like writing equations. You need to write an equation. We know that the formula for the sum of the interior angles of a polygon is 180 times n minus 2. And they say that that is equal to 5940. This is the equation that we can now solve. So this is 180 times this. So how do I get rid of the 180 on this side? I do the opposite operation, which is dividing by 180 on both sides. So I use my division property of equality. So if I do 5940 divided by 180, I'd get 33. So I'm left with n minus 2 equals 33. Now 33 is usually the answer that the people who don't write an equation write down, but that's not right because this is n minus 2 equals 33. I need to add 2 to both sides. So the number of sides is actually 35. So write down the polygon angle sum theorem and then set it equal to the number of degrees that are inside the polygon. Divide by 180, add by 2, and then we find out it's 35 sides. Okay, this one says the each interior angle of a polygon is 140 degrees. How many sides does it have? All right, now there's two ways to do this one. I'll show you both ways. So basically, we've got a regular polygon, and each of the sides is 140. Well, the equation that we could write to do this would end up being, well, 180 times n minus 2. Now, that would be the sum of all of the angles inside of the shape, but then we'd have to divide by the number of sides, and I don't know what the number of sides is. That equation is not the greatest equation to solve at this point. I mean, I could solve it. I could multiply both sides by n, and I'd get 180 times n minus 2 equals 140n. And then I can distribute over here, and I'd get 180n minus 360 equals 140n. Then I'd subtract 180n from both sides and get negative 360 equals negative 40n. And then I could divide by negative 40 on both sides. So 4 goes into 36 9 times, and we'd find out there are 9 sides to the shape. Okay, sorry, you couldn't see the end of my work there. There you go. That's working from the interior angles, but we said at the beginning of the problem, why is it easier to work from the exterior angles? Well, we know that if the interior angles of this regular shape are 140, the exterior angles have to be equal to what? 40, because these two have to add up to 180. Now that I know the exterior angles are all 40, so each of the exterior angles are 40, the equation to solve for this is way easier, because to find each side, we would just do 360 and divide by the number of sides. This is a much easier equation to solve than this one. This one, all we would do is multiply by n on both sides, and we get 360 equals 40n, and then divide both sides by 40. And we get the same exact answer, n is equal to 9. Much easier to work from the exterior angles. Why? Because the exterior angles always add up to 360. So if I take 360 and divide by the number of sides, that's where I'm getting 40 from, each individual angle, since it is regular. Regular means all of them are the same. So you can work from interior or exterior. Exterior is easier because the interior changes depending on how many sides there are. All right, that's all I got for you. Math hard. See you guys later. Bye-bye.